Hello everyone, welcome to Reactive File Labs again. Today we will be doing the Leetcode problem Sudoku solver. It is the problem number 37 and it is also tagged as a hard problem, and it is actually a hard problem. So if you have done Sudoku before, then it might not be that hard for you. But if you don't know how Sudoku is played, then it might take you some time for understanding the problem. But once you understood that, after that, if you if you know how to do backtracking, then it's easy for you. Okay, since I do not know backtracking, because backtracking is kind of like recursion, right? So it's a variation of recursion. So I'm pretty weak in backtracking. That's why it's a little hard for me. But with practice, it will come. Okay, you'll understand, or you will start solving backtracking questions with practice. Okay, even I was scared of it initially. I'm still scared of it. So but I now am able to solve some backtracking questions by myself. Okay, it's not like when I see the question I enjoy, or I feel happy that yes, I got a backtracking question. No, but still I am able to solve some questions on backtracking. Okay, it came with practice, and if you feel backtracking is hard for you, just keep practicing, and you will also be a master in someday. I don't know, I'm not a master, I'm not claiming that. Okay, I am just a teacher who is trying to teach students how to solve questions, that's all. Okay, with keeping every motivational talks aside, let's start solving this problem, and let's see what the problem statement is first, and let's see what are the different ways we can solve this problem and what is the most optimal way to do this. Okay, so the problem statement says, in Sudoku you got a 9x9 grid, right? So this 9x9 grid looks like this. Yeah, I know you know what 9x9 grid looks like, but I'm trying to show you something else here. So this is a 3x3 grid, right? And each 3x3 grid, each grid is a 3x3 grid. Okay, so this is why it is 9x9, because every one of this grid is a 3x3. Okay, so that's why you get 9 rows and 9 columns. Okay, 1 2 1 2, and similarly here you get 1 2 1 2, so 9 rows, 9 columns. Okay, actually, why don't I just make it? I didn't want to make it because I wanted to explain something else here, but okay, so you see this, right? It is 9x9. so now we just do the backtracking as in deleting whatever we did here. Okay, now if you see, the rule says in the 9x9 grid, right, so you have rows equals to 9, you have columns equal to 9, right? Okay, so, and since there are 9, you have to fill digits 1 to 9. Okay, then each row has unique digit. Okay, each row should have a unique digit. This is first rule of Sudoku. Second rule says each column has unique digit. Okay, and third rule says, as you must have guessed, each diagonal should have unique digit, right? No, that's wrong. Haha, got you. This is not each diagonal should have a unique digit. It's like this box, each of the cells in this box should have unique digit. Each cell in a box has unique digit. Okay, right? So the diagonals can be duplicated. For example, let's take an example 1 2 3 4 5 6 7 8 9. Since in this diagonal, if you see the entire diagonal, one has already come, right? So you can again do this 1 2 3 4 5 6 7 8 9. So this is perfectly valid, even though one is coming in this diagonal twice, but one is not repeating in this box, one is not repeating in any box, so that's why it is correct. Okay, so that's what it is. So these are the only 3 rules that you must follow while doing Sudoku. So solving a real Sudoku is actually hard because you might need a pencil, because you will make so many mistakes, or you will have to like look through all the possibilities, all the grids and all, right? But writing a code is much easier compared to solving a Sudoku, because then you are just delegating your task of solving to the computer, right, to the processor. So it will do it for you. You just have to write a simple logic. Okay, so if you see, as you can see, you will say, okay, so what's so hard in it? Why is it a hard problem? Because all you need to do is you have to just do a for loop, okay, for I equals to, or for row equals to 0 to 9, for column equals to 0 to 9, and what you need to do is you need to just check if all elements are equal or are unequal, right? If all elements are unique or unequal, whatever you say, right? This is it. Okay, you can do that, but there is one thing I forgot to tell you. So what happens is you never get a Sudoku empty. Okay, you can, but usually what happens is, because if you get it empty, you will always have one solution, right? So instead, what they do is they do this: 1 2 1 2 1 2 1 2 and 1 2, and here also. So if you see, they pre-fill some numbers for you, right? For example, the example that Leetcode has given, it has 5 3 6 9 8 7 1 9 5 6 3 1 6 5 9 2 8 7 6 8 2 3 4 1 9 8 6 8 4 7, right? So this is the Sudoku that they give you. Like, this is a sample one, but they will give you, like, the numbers may be different in others. Okay, now you have to solve it. Okay, so you have to not only make sure that you put unique numbers in each row, column and box, but also you need to make sure that you adhere to what is already given. Like, these things are uneditable. You have to fill your remaining numbers keeping this thing in mind, right? Great. Now what you need to do is you need to find a way to do this. So what you will do is you can just do what I said earlier. For row equals 0 to 9, right? For column equals 0 to 9, right? In this row and column, what you will do is, let's say it's 9 by 9. So 81 possibilities you have. What you will do is you will just see, first of all, if the board is empty, right? This is called board array. It is a board array which is a 9 by 9 array given to you, right? So in this board array, what you will check is if board, row and column is empty, right? So the empty is represented by dot according to the question. Okay, the numbers are represented by numbers, character. So if it's 5, it means it's a character 5, right, instead of int 5. And after that, this if it is a dot, then what you will do is you will again write a for loop, okay, for digits from 0 to 9. Okay, you will put one digit there. Okay, you will find a place, because you know that it's empty, right? So what you will do is you will put one digit there. Board, row and column equal to digit, right? Not digits, digit. So you will put the digit here, and once you put the digit, then you again call this function. For example, let's say we call this function solve. Okay, so what you do is After putting that digit, you will again call this function solve. Solve means you are doing recursion. Recursion means you have put 1. So for example, what I did is, let's say I put here 1. Okay. Then after putting here 1, or actually digit can be not 0 to 9, it should be 1 to 9, right? Inclusive. Here they are 0 to 9 exclusive. So just to avoid confusion, I will just write it 1 to 10. Okay. So let's say I put 1 here first. Then what I'll do is I'll again solve. Now I know that when the next for loop comes, because this is a recursion, right? The same function will start from 0 to 9. Now we know that after this, I will find that, okay, I have filled this. Now if I check board row column is dot. So this point, last time I had found this at dot, right? But now this is not a dot. So now I will check here, this position. Yes, it is not a dot, right? So it's not a dot, then we'll again try to fix some number. So for example, let's say again, if we fill 1, then if we again try to do solve, then there will be a condition checker which will check and tell us, see, you are repeating 1 here. So now we know that, okay, 1 is not possible here. Then we do backtrack. So what we will do, we will remove it and then we will try 2. Then if it also after some steps it again does not give a solution, then we will remove again and give 3. It is possible that in the end we will find that this 1 is wrong here. So we will remove 1 again. So this will also be another backtracking. So we backtrack, remove 1 and try putting 2 here, and then try all possible combinations at other places, right? So that's what we do. So once we have this, so once we solve, okay, so we check. If we solve, if solve returns true, then we return true. Otherwise, if it does not return true, then what we will do is, we will do board row column equals to again dot, because we found that, okay, because when we placed 1 here, we knew that yes, 1 is not the answer because this one returned false. So we backtracked and we removed this 1 from here. Sorry, we removed this 1 from here. No, I have no idea why I am unable to delete it. Nope. Yep. So we do it here, okay, and we again start the solution, right? So that's what we do. But at the same time, what we need to do, we need to also make sure that, as I said, if solve, okay, if solve. So how does the solve know where to check? Because we didn't write the condition checker, right? We did not write the checker that yes, give me that thing, tell me how it is, how do you say this is not a solution at this moment, right? So for that, what we need to do is, we again, like, then we solve and we need to find a condition. So this condition checker will be somewhere in the beginning, right? This condition checker will do something like this, that it will again write a for loop from I equals to 0 to n, right? Or row equals to 0 to n, 0 to 9, for column equals to 0 to 9, and actually it will check all the rows. It will check all rows for duplicates, right? It will check all columns for duplicates, right? Now if you see, with this logic, what we did was, we made sure that all the rows and columns should have unique, right? But we did not make sure that the boxes should be also unique. So that's when we will start for box, because we know that we have 9 boxes, right? For box equal to 0 to 9, again we will do the same check, okay, do the same check, and again that same check will have again for box equals 0 to 9, will again check for uniqueness, right? We'll do this, and then the backtracking will make sure that everything is fine. But as you have seen, I did not put much effort in this because this solution is not optimized. The reason why this solution is not optimized is because as soon as you fill this, right, as soon as you fill this, what you do is you go and check if all your constraints are satisfied or not. So when you go and check these constraints here, you will always have to go through 81 cells, right? You always need to go through 81 cells. So you put one number, you go do it, check 81 cells. So for every place, for every 81 place, you have to go and check 81 possible combination. So, and it's a backtrack, it grows exponentially, right? It grows exponentially. For example, so let's say you filled 1, right? You did 81 checks. Then you filled 2. You did 81 checks again. You filled 3. Then you did 81 checks again. And after you filled 9 and you did 81 checks, you realize that, okay, this is not an answer. So you backtrack. So every time you backtrack, you find that, okay, here 2 was not an answer. So you did 2 to 81 checks, not an answer. So you tried 3 now. Then you do 81 checks again. So it's like a multiple of 81. So it's a lot, right? So it means 81 to the power something, like those many combinations are there. So that's why this is not optimal, right? This is not optimal. But how can we optimize it then? We can optimize it by remembering some things. For example, what we should do, what check we are doing? We are checking if all the elements in a row are unique, right? We are checking if all the elements in a row are unique. So if all the elements in a row are unique, if for that we are doing the check like for like I equals to 0 to 9, we are checking what that element is. There is some element. Then what we do is we are going to check if this element does not match any other element for j equals to 0 to 9, right? So we are taking 2 for loops for this, right? What if we make a map, or let's name the map rows map, okay? And in that, again, the size of this rows map will be 9 by 9, of course. And 9 means this 9 here will be for each row, right? This 9 will be for each row. And this 9 will be for what? Each digit. So if we know that, so if we know that in one row 5 has already come. So let's say for this row, if you see row 0, 5 has already come. So if we just remember it that, okay, row 0, 5 has already come, it means this is true, right? Correct? Similarly, instead it will not be actually in, I'm just doing this for explanation. In reality, or when you do the code, you will make it row 0, 4, right? Because you have 9 rows, yes, or 9 columns, but you can store the values only till 0 to 8, right? So that's why you will do 0 to 4, but for explanation purpose, I am doing it this way. So row 0, 5 is true. Now you also know that row 0, 3 is also true, and 0, 7 is also true. So row 0, 3 is also true. Row 0, 7 is also true. So what you can do now is, before putting an element in another row, let's say you get a row column, right? So you get a row, let's say row 0, you get row 0 and column, for example 9, because, column 8, because we know that 8th column is empty. So if you are putting something in row 0, 8, right? Let's say you get, after all the iterations, backtracking is giving you, let's try by putting 5. So if you are getting 5, what you can do is, instead of checking all the rows and columns, what you can just do is, you can just check if row 0, 5 is true or false. You will see here that yes, it is true. Then you know that you cannot just put 5 there. So you just saved yourself so many steps. You know that, let's try 6. So you will try 6, then again backtracking will happen later. But while putting that element here, you don't need to spend your n square time or the 9 square time in the checking. What you can do is just look at your map, right? And yeah, instead, or actually it should not be row, it should be board, right? Board 08. And this is not row, this is rows map. This will also be rows map. And this will also be rows map. So you will store these things, you will remember these things in the rows map. Similarly, you will have another map called cols map for mapping columns, right? 9 by 9 size. And you will also have boxes map for remembering the boxes. And once you have these, all you need to do is just run your code. Just before putting an element, just check in this map. Instead of writing a complex logic for checking, just do this and you will have your answer. So if I have to give you a pseudocode for this, what I will do is first I want you to see, actually there is one more thing I should be pointing out. So for example, let's say the problem is here. So we have boxes, right? I will just separate the boxes first. So we have one box here, we have one box here. Then we have one box here, and then we have one box here. Correct? So we have these boxes. Now if you see, we have an element. Now if you see, we have an element here, let's say at 6 by 6. Okay, row 6, column 6. It means for us it will be row 5, col 5, right? So how do we know which box it is in? If you see, row 5 and col 5 is 0, 1, 2, 3, 4, 5 here and here. So something which is at this location, right? How do you know what position this is in box, which box it is? So if you see, it is box number what? It is box number, if we name it like this, box number 1, box number 2, 3, 4, 5, 6, 7, 8, 9. You can also say this is box number 2. That's fine. That's up to you. It is just the way I like. Okay. So now you know that yes, this is box number 5. But how will you calculate this is box number 5? You cannot just guess it, right? So for that, the calculation goes like this: row by 3 times 3 plus column by 3. Okay. So now your row is 5. So 5 by 3 is 1 point something, which means 1, right? So it will be 1 into 3 plus column by 3 is what again? It is column by 3 is 5 by 3, which is again 1. So it means this is 4, right? Is this right? I get confused. It should not. It should be 3 plus. It's box 4. Oh, sorry. Yeah, right. It's box 4. This is correct. Actually, this is row by 3 is what? 5 by 3 times 3 plus 5 by 3. So this will be 1 times 3 plus 1, which is 4, right? So box 4, right? But box 4 is this because I made a mistake. So what mistake I made was not in the calculation, but in this. Oh, okay. I cannot delete anymore. So I'll bring everything back first. The mistake that I made was this. Yes, since everything is starting from 0, why is the box starting from 1? So box will start from 0 also. So this will be 0. This will be box 1. This will be box 2, right? This will be box 3, 4, 5, 6, 7, 8. So that's why. So now you will see we are getting the box number as 4. And let's find out something else also. Let's take randomly. Row is 7, column is 2. So 7 by 3 times 3 plus 2 by 3. 7 by 3 times 3 is 2 times 3, which is 6, right? 6 plus 0, which is 6. So if you see, 7th row is 0, 1, 2, 3, 4, 5, 6, 7. This is 7th row and second column. Second column is 0, 1, 2, second column. 7th row and second column, the number comes at this point. If you see, this is box number 6, right? This is box number 6. So 0, 1, 2, 3, 4, 5, 6, 7, 8. So that's how we do the box calculation also. So if you find this in my code, you remember where it came from, okay? Don't get confused. Okay, so now time to give you the pseudocode for this. So what we do is, first of all, we'll have our rows map 9 by 9, initially everything will be false. Same goes with calls map 9 by 9. This will also be false, and same goes with box map, which is also 9 by 9, and this will also be false, correct? Now what we do is we initialize it as in whatever the values are already there, let's fill it, right? So for that, what we do is we will write a for loop which goes from I equals 0 to 9 for j equals 0 to 9, okay? If board ij is dot or not dot, actually, if board ij is not equal to dot. So if it is not equal to dot, it means it's some character. So the number will be, because the numbers are from 1 to 9, but the rows or the index are from 0 to 8, right? So that's why the number will be board ij minus character 1, right? So if the number is 9, right, so what we will get is character 8. Okay, so now what we do is we will just fill it, means we will get rows map of I and num as true, because as I mentioned before, we are mapping. If you don't understand this step, please go back and watch where I explained why we are doing this, why it will be num instead of ing. Okay, again the calls map of j and num will also be true, and we also need to check box, right? So box map of how will we find which box is it? So it is I by 3 into 3 plus j by 3 num equal to true. So if you have any problem understanding anything in this step, please go back in the video and watch that part again where I had explained why this is going to happen, okay? Because if you don't understand it, I think you will have a hard time understanding the other parts of this video, like the things which are coming further, okay? So please try to understand this thing very well. This is very important. This is very, very important. So this is the initialization step of the board. So this is very important. Please understand that, okay? So once we have initialized it, all we need to do is just solve the problem. Solve the problem as in here, what we will do is we will write again the same thing. The for loop will go from I equals 0 to 9. For loop will go from j equals 0 to 9. Okay. Again we will check if, so last time we checked if board ij is not equal to dot. It means it was not empty because we had to fill it. Now since we have to fill only the dots, right? So we'll check if it is dot, right? If it is dot, then we will check the numbers. So for d equals 0 to 9 that we have to fill, okay? For d equals 0 to 9, we will find which box ID, because we know that row and columns are from I and j. So we will try to find out which box does it belong to. So the box ID will come from I by 3 into 3 plus j by 3, right? So we know the box ID also. So what we need to check is, are those row, columns and boxes empty? So for checking that, what we will do is, actually I'll use brackets so that you don't get confused where what is starting and ending, okay? So if rows of what, I and d, it means if that number is already present in that row. No, yes, it means if it is false, it means it is not already present in that row, and we call it rows map of I and d, right? And we'll also check calls map of I and d, and we'll also check box map of what, box ID box ID and D. So if we are sure that that number is not present in that row, that column, that box, then what we will do is we will put that number there in that board. Board ij equals D plus character 1, right? D plus character 1. Now, once we have put that number there, we need to populate the maps also. Rows map of I and D, calls map, because it's not empty anymore, right? So we have to make it true. Calls map of JD, and also boxes, box map of box ID and D. All of this will be true, right? We'll put all of this as true, and then we will check if solve function, it comes with board, right? So I'm just not writing the board. If this is true, then just return true. If that is true, return true. If that is not true, okay, solve function ends here. So if that is not true, then what we will do is we'll backtrack. So board ij will now again be dot. Last time we had filled it with a number, then we'll make it again dot. Okay, so once it is again dot, and not only that, we also need to make sure that this rows map, actually where is that thing? Yep. Oh, I don't know if this copies. I think it moves, so that's why I'll just write it. Rows map of ID, calls map of ID, and box map of box ID and D. These are all false, because we have to backtrack. So we have to just reverse all the operations that we did earlier. So once all this thing is done, then it means that the for loop ends here. Two for loops end here. If two for loops means, so if you see, this for loop ends here, right? This for loop and this for loop. Okay, once those end, we know that, okay, it means we did not find anything in that row, that column. Okay, so after this we will just return false. Once we return false, then no, sorry, I think I made a mistake. Sorry, yeah. So there is another for loop. This if condition. So this if condition is there. So this if condition and this for loop ends. Okay, so actually let it be there. So once it means that this if condition also ends, this for loop check is also ending. It means that what happens when we return false here. Okay, let's see till this point. We know that, okay, we have filled some number here. Okay, if nothing comes, okay, if nothing comes, then we know that, okay, for this digit, all the digits we checked from 0 to 8, 0 to 9, 9 is not inclusive, all the digits we checked for this row and column, and nothing is filling here, so we return true. Like some Sudokus are unsolvable, right? Return false. So in that case, we say that, okay, just return false. Okay, if not, then we will just continue. It did not return false, means we found something, so we just end all the other for loops there. Okay, one for loop, two for loop, 5. Okay, sorry, there is one more, this one also. Okay, so we end this and this now. So 1, 2, 3, we return this. So once we know that we returned all of these, all the for loops ended, and still it did not return false, then we know that we have our answer, and we just return true. And once we return true, we end our function, the function which was solve. Okay, once we have this, we have our answer. So this is the pseudocode. Actually, this is the code, you can just use it. Okay, just try writing your own code, and I'm pretty sure you will understand it, and hopefully this video helped you understand how backtracking works in Sudoku solving, and how this Sudoku problem is optimized here. I hope you understood this portion, which is a very important portion in optimizing the Sudoku. As from interview perspective, usually these kinds of questions should not be asked because 30-40 minutes is not enough for this kind of problem. But if it is asked, the expectation should be, and ideally if I am the interviewer, if I ask this question, my expectation is that I want to check if the candidate understands backtracking. I am not expecting this entire solution. What I am expecting is if the candidate can convey to me that how he will apply backtracking there, okay, and also how that person will optimize it. So if somebody talks about this approach, okay, and this approach where we do the backtracking, how we do the backtracking, this approach, these two, okay, and this also, like first you do something, then you undo it, okay, this is backtracking. So if somebody talks about this much, I will just send them to the next stage, okay. So this is the these are the main portions of code, because everything else is just for loop, right? The main logic is in the backtracking and your optimization. If somebody only talks about this thing, I will ask them, what's the complexity? What is the time complexity? What is the space complexity? And if they tell that correctly, that yes, it is not optimized, and if I ask them again that, tell me, how can you optimize it? And if they talk about this thing, they're just like, they're higher, okay? They're good. If they just tell the time complexity of this step wrong, like they say it's linear or it's n square, then they are like straight reject. It means they memorize the solution, but they don't understand how it works, okay? They don't know how time complexity works. They don't know how time complexity is calculated. So that's why it's a straight reject. But if you just do this and you tell the time complexity and space complexity correctly, you are still a good, okay, you will be passed. But if you talk about this also, the interviewer will be impressed, okay. So yeah, that's all. Enough talks from me. Hopefully this video helps you, and yeah, I don't have anything else to say. Have a good day. Please don't forget to like, share and subscribe, and please do like, share and subscribe. And yeah, I have very low number of subscribers. Please try to increase that. Share this video among your friends. If I have more subscribers, if I see that more people are liking my video, it will give me motivation to keep making these more videos, okay. Otherwise it's just like I don't get motivation. That's why I just don't feel like I should spend effort like 40-45 minutes in making the video, and then another half an hour uploading the video, adding the description. So yeah, please help me keep motivated, okay. It helps me also. So yeah, that's all. Enough from me. Have a good day. Bye.